Okay guys, today we're going to continue our work with scatter plots, and we're going to talk a little bit more about correlation and how it can help us. So on number 1 it says the scatter plot below shows the average ticket price in Major League Baseball from 1997 to 2006. Part A says determine what relationship, if any, exists in the data and explain. So if you notice, the dots, the points on our scatter plot, are all kind of moving up together in the same general direction. So that means we have a positive correlation. Now to explain, if you'll remember from last lesson, we want to combine the axis titles and make a nice little pattern here. So we'll start with as the years, or as time in years increase. Then we'll combine these. The average price of baseball tickets also increases. So I had as positive correlation, as the years increase, the average price of a baseball ticket also increases. Now you feel free, you can pause the video and write that down if you need to. Now part B says use the points 1999 and 1998, 1360, and 2003, 19 to write the slope-intercept form of an equation for the line of fit shown in the scatter plot. Now, if you'll notice, they have a line drawn with all of these points on the scatter plots. Notice this line does not go through every single point on the scatter plot, because the points are not in a straight line, but it does have a nice general representation of the points. It's showing that it's going up, and it's going up in a certain pattern. For example, if I were to draw a line like this, yes, it would be going upwards, but it would not represent the points very well because all of the points would be below it. So the line of best fit is a line that they like to use that kind of cuts the points in half, shows them like, okay, we have them, here's a couple of points on the line, but majority is either above or below. Now, this line helps us to estimate things in the future, meaning that that can help us figure out like what's going to happen out here if this trend continues. It won't make it exact, but it'll give us a nice estimate. So the problem wants us to use these 2 points here to write an equation in slope-intercept form. Well, we definitely know how to do that. First, we just need to find the slope. So we'll say m equals, and we'll say y sub 2 minus y sub 1, so 19 minus 1360 over x sub 2 minus x sub 1, so 2003 minus 1998. So if we get out our calculators, I'm going to take 19 minus 1360, and I'm going to get 5.4, but if we're dealing with money here, that's $5.40, over 2003 minus 1998, which we should know is 5 years. So that's saying that it has been increasing $5.40 on average in 5 years. But we want to make it with a denominator of 1. So let's see if I can simplify that. $5.40 divided by 5 gives me 1.08. So I have a slope of $1.08. It's saying $1.08 per year. Now that I have my slope, I want to choose one of these two ordered pairs to put it in point-slope form. I'm going to choose this one because my decimal looks a little easier. And I'm going to say y minus y sub 1 equals my slope times the quantity of x minus x sub 1. And finally, all we need to do is distribute and solve. So y minus 19 equals 1.08x. And then I have a positive times a negative, which gives me a negative. And I'm going to take 1.08 times 2003, and I'm going to get 2163.24. Next to solve, I'm going to add 19 to each side. That's a 19, come on. So if I have negative 2163.24 plus 19, I'm going to get negative 2144.24. So I'm going to come over here. Y equals 1.08x minus 2144.24. So this is the slope-intercept form of the line of best fit. So this will represent this equation. This equation is going to represent this line, and it's going to kind of help us estimate how much baseball ticket prices will cost each year. Now notice this is not exact, but, and we also kind of have rough numbers here, but these are real world problems, so you're going to get some real world answers, and everything in the real world, I'm struggling today, is not always pretty. So now I'm going to box that so it's easy to see. On part C it says use your equation to predict the ticket price for 2014. So I'm going to use this equation, and if I want to know the price in 2014, years were in the x value, so I'm going to substitute 2014 in for x, so 1.08 times 2014 minus 2144.24, and I'm just going to substitute that directly into my calculator. So 1.08 times 2014 minus 2144 and 24. And we get an answer of $30.88. Now remember, this is just an estimate. It's saying if the pattern continues like it has been, this is what the price for a baseball ticket would be in 2014. Now you guys are smart enough to know that that's probably not always the case because other things come into play here. For example, if the baseball team would have won the World Series, ticket prices would go up. If they're not doing so well, ticket prices might not go up as much. And it also depends on where you get a seat at. If you get a seat in the nosebleed seats, it might be cheaper. If you get a seat right behind a dugout, it might be a little more pricey. So this is just an estimate. It is not exact. Now in part D it says explain the meaning of the point 2005, 2195. So we just need to explain what this point means. Now 2005 is pretty self-explanatory. That's the year. So I would say in 2005, then the y value, the 2195, was the y value over here, and that was the average price. So I would say the average price. Now I have to be a little more specific. I can't just say the average price is, because I have to say what I'm talking about. It's the average price of a baseball ticket was $21.95. So they just kind of want you to explain what that ordered pair means. Alright, let's try it again. So on number 2, it says, the graph shows the number of cases of foodborne botulism in the United States for the years 2001 to 2005. Part A says, determine what relationship, if any, exists in the data and explain. Now notice my points are all kind of going downwards together, so that's going to be a negative correlation. And to describe it, we start with the x-axis. So as the years increase, then we kind of combine these two. We can't just say the cases decrease because that's not enough information. We want to say the cases of, or the number of cases of U.S. foodborne botulism decrease. So again, you can pause the video and write that down if you need to. As the years increase, the number of cases of U.S. foodborne botulism decrease. Now, Part B says, draw a line of fit for the scatter plot through the points 2002, 28, and 2005, 18. So we need to get out our straight edge here, and they want us to draw a line of best fit through this point and this point right here. So using our straight edge, we connect it all the way through and end it with arrows. So that's going to be kind of a nice line to represent what's happening in this study. Now Part C says, write the slope-intercept form of an equation for the line of best fit. So they want us to use those two ordered pairs that we chose and write an equation for the line of best fit. So again, we're going to start by finding the slope. So we're going to say take y sub 2 minus y sub 1, so 18 minus 28, over x sub 2, which is 2005, minus x sub 1, 2002. Now 18 minus 28 is negative 10. 2005 minus 2002 is 3, and I have a fraction of negative 10 over 3. Now, we cannot simplify negative 10 over 3, so I'm just going to leave it like that. You will be working with some pretty rough fractions this section, and that's okay. So now I just choose an ordered pair and go from there. So I'm going to choose this guy, and I'm going to say y minus y sub 1 equals my slope times the quantity of x minus x1. So y minus 18 equals negative 10 thirds times the quantity of x minus 2005. Now to solve, all I need to do is distribute and add. So I'm going to, I'm going to distribute negative 10 thirds, and I'm going to get negative 10 thirds x. And then I'm going to take negative 10 thirds times negative 2005. Now just a reminder, we're going to start with the signs. Negative times a negative is a positive. And then I'm going to take 10 thirds times 2005. So in my calculator, I'm going to say parentheses 10 divided by 3 times 2005. And I get a decimal. Well, I want that to be a fraction. So however your calculator turns it into a fraction, I'm going to hit math, enter, enter. And I'm going to take I get 20,050 over 3. Now, some of your calculators might not have been as nice as mine. Some of your calculators might not have turned that into a fraction. So I'm going to remind you quick how to multiply them together if you want a fraction as a result, and your calculator won't do that. So if you're taking 10 thirds times 2005, that's the same thing as 10 over 3 times 2005 over 1. And you'll just take numerator times numerator and denominator times denominator. So 10 times 2005 gives me 20,050. And then 3 times 1 gives me 3. And then you know that can't simplify since your calculator wouldn't give you a fraction. Next, what I need to do is I need to add 18 to each side. So I want to take 20,050 over 3 plus 18. So in my calculator, I already have that 20,050 over 3, and I'm going to add 18, and I get 20,104 over 3. So come over here, and I get y equals negative 10 thirds x plus 20,104 over 3. And that's my final answer. I know that's a rough answer, but again, that's a real world problem for you. Now, if your calculator wouldn't give you a nice fraction on that one as well, I'm just going to remind you how to add fractions. So I'm going to have 20,050 over 3 plus 18 over 1. But to add them, these have to have common denominators. So I want to have this as a denominator of 3. So I take 18 times 3, and I get 54. So this will equal 54 over 3, and I want to add that to 20,050. So 20,050 plus 54 is 20,104, and then you take the 3's and you have a denominator of 3. Alright, on the next page, number 3, it says the graph shows the average maximum longevity of various animals in captivity. So I'm going to explain this graph to you before we move on. They're saying, here's a graph, and we're talking about longevity of animals in captivity, so how long animals can live while in captivity. Now, the animal's average longevity is compared to their maximum longevity. So they're saying, for example, here, if we've had an animal that has an average longevity, an average lifespan of 15 years, it has lived up to a maximum of 40 years before. Or here, we've had an animal that has an average lifespan of 25 years, but they've had one that's lived up to 50 years before. So just so we know, that's how to read the graph. Now it says determine what relationship, if any, exists in the data and explain. So again, these are all kind of going upwards together. So I'm going to say that this has a positive correlation, and as the animal's average longevity increases, the animal's maximum longevity while in captivity also increases. So I said positive correlation, as animals' average longevity increases, their maximum longevity also increases. Now part B says draw a line of best fit for the scatter plot through the ordered pairs of 15, 40 and 35, 70. So here's 15 and here's 35. So I just want to draw that with a straight edge, connect it all the way through, and end it with arrows. Okay. Now part C says write the slope-intercept form of an equation for the line of best fit. So just like we did on the front page, we're going to start by finding the slope. So 70 minus 40 over 35 minus 15. Now 70 minus 40 is 30. 35 minus 15 is 20. And 30 over 20 reduces to 3 over 2. Now I just need to choose one of those two ordered pairs to put into point-slope form. I'm going to choose this one because these two numbers are smaller. And I'm going to say y minus y sub 1 equals my slope times the quantity of x minus x sub 1. So y minus 40 equals 3 halves times the quantity of x minus 15. Now I can distribute, so y minus 40 equals 3 halves x. I have a positive times a negative, which gives me a negative, and I want 3 halves times 15, so parentheses 3 divided by 2 times 15, and I want to turn that into a fraction, and I should get 45 over 2. Next to solve, I just want to add 40 to each side. So in my calculator, I need to take negative 45 over 2, and I want to add 40 to that fraction. Make sure you turn your answer again into a fraction, an improper fraction, and we should get y equals 3 halves x plus 35 over 2. So these fractions weren't nearly as bad as the ones on the front page. Now on part D it says, predict the maximum longevity for an animal with an average longevity of 33 years. So animals' average longevity was the x-axis. So I'm going to substitute that 33 in for x, and I'm going to get y equals 3 halves times 33 plus 35 over 2. And all we have to do is put this directly into our calculator. So 3 halves times 33 plus 35 over 2. And we get a nice answer of 67. So an average longevity of 33 years should have around a maximum longevity of 67 years. Alright, last one. Number 4 says the scatter plot shows how much ice cream the Sprinkles Sundae shop sells versus the high temperature on that day. Part A says determine what relationship, if any, exists in the data, and explain. So again, these points are kind of all going upwards together, so I'm going to say that's a positive correlation, and to describe it, we start with the x-axis. The x-axis is temperature in degrees Fahrenheit, so I'm going to say as the temperature in degrees increases, then I can kind of combine the y-axis and the title. The sales for Sprinkles Sundae shop also increases. So as the temperature in degrees increase, the sales for Sprinkles Sundae shop also increases. Now part B says draw a line of fit for the scatter plot through 72, 524 and 56, 202. So I'm going to get my straight edge here, and 72 is about right here, and 56 is right here. So I want to go all the way through 56 and all the way through 72 and end it with arrows. Alright, now part C says write the slope-intercept form of the equation for the line of best fit. So just like we had on the past 3 problems, I would like you to pause the video and write the equation between these 2 points. You will have some fractions, and that's okay. Leave them as improper fractions. Alright, hopefully when you found the slope between those two, you got a negative 322 over negative 16, which simplifies to 161 over 8. Then I put it into point slope form and got y minus 202 equals 161 over 8 times the quantity of x minus 56. I distributed and added 202 to each side, and I got y equals 161 over 8 times x minus 925. Now part D says, explain what the point 65, 412 means. So 65 is my x value and 412 is my y value. Well, the x value represents temperature in degrees Fahrenheit, and the y value represents sales in dollars. So this means when the temperature is 65 degrees Fahrenheit, Sprinkles Sundae shop had 400, oh, not has, had, and $12 in sales. Alright, that wraps up this lesson. If you guys have any questions, please make sure to come ask.